are safe and hope you are healthy. And once again, welcome to All India Hams Radio. And my name is Siddharth Bhoge, and I am the CEO and founder of Cyronics Innovation Labs. And we primarily deal with software defined radios for 5G and electronic warfare and even the automotive sector. I'd like to thank Vilas
QRZ, QRZ. Welcome to Pune Echolink Repeater.
Good morning, friends. I am Dilip Bapat, Victor, uniform number 3, uniform Echo Lima. Once again with you as Pune's VU2 Echo November repeater morning net controller. Now, welcoming all the stations to this net. And now, first of all, I am calling any VHF repeater station there on the frequency. Come in, please.
V3 Foxtrot Mike.
Roger. Thank you very much. VU3 Foxtrot Mike Deshmukh sir joining to Pune morning net via VHF repeater. Go ahead. Good morning.
Good morning, V2, V3UL, and all other friends listening on this frequency. This is a regular check-in about weather report. 23 degree Charlie with 42% humidity. Bright sunny morning, cool morning. Very comfortable weather as compared to summer season. Mike, back to you. V3UL.
Roger. Thank you very much. VU3 Foxtrot Mike Chandrakant Deshmukh sir. As usual, coming loud and clear. Finance plus Y VHF repeater to equaling. Thanks for my report. Thanks for WX report. And yes, please stand by because today we have a special Tech Talk program will be presented by our great ham radio operator, none other than Oscar Papa Yankee, and he will be presenting us the SDR radio information. So please stand by and please join us on YouTube live also. 73 is good day to you for the time being. Now we have VU3 Oscar Papa X-ray. Atul Kulkarni sir, I will not call you right now. I will definitely give mic straight away when our program will start. So I am giving mic to Oscar Papa X-ray. Coming please, Monica madam. Good morning.
VU3UEL, this is VU3 OPX. Good morning, sir, and good morning to everyone on the frequency. Just a regular check-in and excited for today's Tech Talk. And over to you, VU3UEL.
Roger, thank you very much. VU3 Oscar Papa X-ray, Monica madam joining from Katras, Pune with such a nice loud and clear audio. And yes, definitely everybody is excited and eager to listen to the great Oscar Papa Yankee Atul Kulkarni sir. Okay, stand by please and do join us to the YouTube live also. Now I am putting mic to VU2, Mike Oscar Alpha. Come in please, Mohan sir. Good morning. Let me know whether you are still on the transmitting from Pune or from Chennai. Go ahead. Good morning. Kale Vadakkam.
Yankee Zulu, why is it?
Okay, Mike Oscar Alpha, come in please, sir. Good morning.
Yankee Zulu, why is it?
Okay, he's having some issues. So we have our great ham radio operator from Pune, old man Yankee Zulu, Sampath sir joining from via VHF repeater. Good morning, sir. Go ahead.
United Echo Lima, net control, V2YZ. Very pleasant morning to Dilip. Good morning to all on frequency. Nice to hear you all. Good signal. 59 plus. Bright sunny morning here. 73 is good morning. United Echo Lima, YZ. Sierra Bravo.
Yes, Roger. Thank you very much, Yankee Zulu, Sampath sir. As usual, coming very loud and clear. Finance plus is the report for you via VHF repeater to Echo Link. stand by please for our special Tech Talk program. 73 for the time being and good day to you. VU2 Mike Sierra Bravo Milind sir, come in please. Good morning.
Roger, VU3 United Echo Lima, and all the friends on the frequency, very good morning to you. Good morning Sampath Saab, good morning Vilas, Atul, Sripad, Mangesh, and all the friends on the frequency. You have 5-9 plus, beautiful signal, Dilip, as usual. I'll be standing by. QRU 73, good day, good DX. Bye-bye, cheer you. Over to you, VU3 United Echo Lima, VU2 MSB, over.
Plus is the report to you, and stand by please and join us for our YouTube live program. Now I am giving mic to our most regular DX friend from USA, joining from South Florida, Whiskey November 4 Victor. Come in please, John sir. Good evening to you there in Florida.
Victor Uniform 3 Uniform Echo Lima WN4V. Well, good morning India, and good evening North America, or good night North America. 18 degrees C, 78% humidity. And I will be listening on Echolink for your Tech Talk. Echolink is best for me for your Tech Talk. I'm looking forward to that. Everything is just fine here. We're safe and healthy. And I will turn it back to you and stand by for the Tech Talk. VU3 UEL WN4B, South Florida.
Roger, thank you very much, John sir, joining from South Florida, coming very loud and clear as usual. Thanks for WX report, and yes, do join us on that YouTube live program. And hope to meet you today evening net also, and if you wanted to ask any questions, do join them for question and answer session also. For the time being 73s, and good night to you. Now we have RTW Shanmugam sir joining from Coimbatore. Kale Vadakkam, come in please.
Present good morning, Dilip. Present good morning, all friends on this frequency. Fine and very good copy. Cool and comfortable morning, but daytimes are very, very hot here. And I'm QRT Unit 73, wishing all safe and present and wonderful Sunday. I will switch over to YouTube to listen to TikTok program. V3 Uniform Echo Lima, V2 Romeo Tango Whiskey, over.
Roger, thank you very much, RTW Shanmugam sir. Very loud and clear audio as usual. And yes, sir, do join us on that YouTube live. 73 for the time being. Good day to you. VU2 RNC. Ram sir, come in please. Good morning.
VU3 UEL, this is VU2 RNC returning. Very good morning, Baba Sahab. Good morning to all friends on frequency. Coming 5 and 9 here, very good signal, no traffic, QRU 7. Over.
Roger, thank you very much, Ram sir. Joining from Agra city, as usual, very loud and clear audio. I am copying here in Alibag via equaling to equaling. And do join us for that YouTube live. 73 for the time being. Good day to you. Now we have VU2 NDF Nandu Kaka, our UHF net controller, and VHF regular net controller. Come in please. Good morning.
Good morning, VU3 UL, Bapaji. Good morning to you and others on the frequency. No traffic, just waiting for the Tech Talk. 73s and good day to you and others. Back to you, VU3 UL.
Roger, thank you very much. View to NDF Nandu Kaka joining from Karvenagar, Pune. Very loud and clear audio as usual. Stand by please on the frequency for our Tech Talk program and join us to the YouTube live also. 73 is good day to you. VU3 Hotel Quebec Papa Arupji, come in please. Good morning.
VU3UEL, this is VU3 HQP returning. Good morning to you and good morning to all other friends in the frequency. Yesterday we had a very good rain and at present bright and cool and comfortable morning here. HQP back to VU3UEL. Over.
Yes, Roger. Thank you very much, Hotel Quebec Papa Arupji. Thanks for joining from Agartala. As usual, very loud and clear signals. Hope to meet you today evening net 73 for the time being. And yes, join us on YouTube live straightway. Now we have Sierra Papa Foxtrot, Dr. Bhatnagar sir joining from Bhavnagar. Come in please, sir. Very glad to see you. Go ahead. Good morning.
Good morning, everybody on the Ecolink net, and good morning to you, Dilip Bapaji, especially. I am also joining here for the Tech Talk, and I will be waiting for the Tech Talk on the YouTube link. Nothing else for the net right now. So 7-3, have a great day, Dilip ji and all others on the frequency on this net. 7-3, bye-bye.
Roger, thank you very much. View to Sierra Papa Foxtrot, Bhatnagar sir joining from Bhavnagar, coming very loud and clear. And yes, definitely, I also want you to be with us on that YouTube live program. If any question you wanted to ask, do join them for YouTube live question answer session. And after that, we'll have a special question answer session on Ecolink also. This is just for your information and everybody's information. Friend, it is nearing to 8:30 now. I am giving mic to VU to VPR Rabde sir. He will give some introduction to us about Oscar Papa Yankee. No doubt, no need to introduce him because he is such a wonderful personal. Not only that, he is a technical specialist by all means to Pune AMS with our OUM there. And definitely today's program will be such a nice, informative program. Thank you so much, all the stations, and I'm requesting everybody, when our Tech Talk program will be live on YouTube, please don't transmit on this Ecolink platform. So just wait and on the standby mode remain on this platform and join us on YouTube live to listen entire program. So 73 is from my side for the time being, and I am giving mic to my guru, VU to VPR Rabde sir. Take it up and do the needful.
VU3UEL, Net Controller, VPR. Good morning, Dilip. Good morning, everybody on frequency. Welcome to the Sunday Tech Talk of Pune Ham. On first Sunday at 8:30 a.m. And today we will be listening to Siddharth Bhoge. He is the director of Cyronics Innovation Labs on SDR and its application, especially in 5G and electronic warfare. Siddharth Bhoge is a director at Cyronics Innovation Lab in Pune, and he is the founder of Cyronic Innovation Labs, Pasar. So he is a co-founder of so many companies. I have shared the biodata with you all, and he has a good experience. Basically, he is a qualified person, and he has done a lot of activities related to ham radio. Basically, he is
everybody is able to listen now. And I was talking about our specialist in SDR technologies, and Quasar is the platform for various softwares. So without spending much time, I will request applications in 5G as well as electronic warfare. Over to Siddharth Bhoge.
Hello everyone, and hope you are safe and hope you are healthy. And once again, welcome to All India Hams Radio. And my name is Siddharth Bhoge, and I am the CEO and founder of Cyronics Innovation Labs. And we primarily deal with software-defined radios for 5G and electronic warfare, and even the automotive sector. I'd like to thank Vilas Rabde sir for giving me this opportunity to present myself and present Quasar, the brand by our company, which aims to be the world's largest software-defined radio app store. And the brand itself is called as Quasar. And primarily in this series, or in this lecture, I'm going to talk about the uses of software-defined radios in automotive, in electronic warfare, and in the 5G area, and what we do and how we can have or come together to build a better SDR approach to these solutions. So with that, I'd just like to give a brief background about myself. To all the RF enthusiasts out there, I am not a typical RF guy. I completed my master's in University of Southern California in computer engineering, specialization into data science and artificial intelligence. There I came across this use of software-defined radios, and that helped us to crack certain problems when I was sitting in the lab there. And that is how the journey began. So I'm not a traditional RF person, but a software person who has been using data science frameworks like TensorFlow or PyTorch, not for the traditional neural network or the data science, but for SDRs and real-time processing in software-defined SDRs. I was lucky enough to play with an oscilloscope before I could play with a computer because of my father, and that is how my journey with electronic instruments began. And I once again thank Vilas Rabde sir for giving me this opportunity to present before you, the use cases, different works, different apps that we are developing in this field, and why and how we are focusing on software-defined radios. I will not keep the session very big, but as small as I can, looking forward to interacting with you more and more questions. So I will begin my session with Quasar, with the aim of being the world's largest software-defined radio app store. Primarily, we work in the field of 5G, electronic warfare, and automotive radio frequency apps using software-defined radios. And then I'm going to go through the following topics. The basic SDR terminology. Is it really a new technology? Where are the SDRs used? Software-defined radios used? What exactly constitutes or what exactly is an SDR? The beauty of SDR or software-defined radios, the role of our work or Quasar in software-defined radios, what are the different applications that we can build with software-defined radios, and then I'll go through some of the applications, real-world applications that we have implemented using software-defined radios. So I often say that it is often a misconception that software-defined radios is a brand new technology. It's not really a brand new technology. So where exactly one has had the opportunity to see software-defined radios? You have your SATCOM signals like GPS or the DBBS2X signals that the dish set-top box in your at your home has. So traditional SATCOM signals. Then you have cellular signals like GSM, CDMA, LTE, 5G. So a lot of cellular applications can be heavily developed using software-defined radios. You have tons of IoT applications like Bluetooth, LoRa, Sigfox, NB-IoT, which can be actually built using software-defined radios or which can be hacked using software-defined radios. So these are different communication technologies that usually IoT platforms leverage on. Medical, so we were actually surprised by the use of software-defined radios in the field of medical, with MRIs and ECG signals and also neuro signals. So, some of the developers on the Quasar platform actually use this to build their own applications on the medical field. Electronic warfare, so you have UAV jammers, signal interceptors, threat simulators, and so on and so forth. So you have many applications of software-defined radios on the electronic warfare front, and this is the latest hot topic by the government of India and in general in the cyber warfare world. The cognitive or the intelligent radios who are aware of their surroundings, or software-defined radios who are aware of their surroundings to create dynamic or to receive dynamic signals. So software-defined radios are probably everywhere wherever there is signal processing. This may be a stretch, but yes, may be true. And it's not really a brand new technology. In fact, few of the first software-defined radios date back to 1970s. So software-defined radios are everywhere, and we have seen them almost in all the fields and constitute of a very large industry, a $34 billion market, which is there to capture, which everyone is eyeing for, and it's pretty spread. It's diverse, and I'll go upon the depth and the landscape of this market following in the following slides. So what exactly are software-defined radios? So as any radios, obviously there is an antenna, there is a front end or the analog front end, and there is some processing unit, an FPGA or DSP with a small ARM processor or something which governs the analog front end, and then there is a custom software block that is written. So all the hardware functionalities which were there in traditional radios are essentially now governed by the software. So just by changing the software stack on the same hardware, we can actually create different receivers and different transmitters with the same hardware. So the same software-defined radio can be used as a Bluetooth receiver, and the same software-defined radio can be, let's say, used as a drone receiver. So the frequency is basically tunable, and then the entire algorithm can be also tunable. The messages, the real-time parallel engines, all can be made synchronized with each other, so that the same hardware block can be actually used as two different types of receivers or transmitters for that case, just by changing few lines of code. So that is the exact beauty of software-defined radios and why they are really, the hot topic in the current electronic warfare or the cyber warfare front. So the basic importance of software-defined radios. So anything probably in our lives can be categorized into two things, that is the cost and the time for development. So if these software-defined radios were not in picture, the traditional VXGs or vector signal generators, or the traditional, even some of the VNAs are very costly, and the hardware development for these kinds of RF hardwares is also a long process and involves a long amount of time. With software-defined radios, basically you have hardware boards in the range of $500, or I know some of you guys are trying to even bring that price down. Then you also have RTL SDR dongles, and basically they are commercially off the shelf available. So you don't have to, you know, spend a lot of amount of time in, developing the RF part of the communication, but focus more on, let's say, adaptive scenarios, your error rates, your power, or your MIMO patterns, or your message patterns, or the intelligent things, rather than just the RF things. So that is the exact importance of software defined radios. So software defined radios are beautiful, okay, but then what am I missing? Why are they not the silver bullet, or why do not they solve all the different problems that are there in the RF world, right? So that is exactly what Quasar intends to do with software defined radios, and let's see how. The issue, ironically, with software defined radios is that the software part of the software defined radios is still a bit immature. So you have some frameworks who have done some scratch amount of work for the software of the software defined radios, but basically still the software, if we are able, or we can, or we are finding vendors and teams for the development of software defined radios. Let's say I want a LoRa receiver, or a WiMAX receiver, or a transmitter on my software defined radio, or I want a MANET ad hoc network with my software defined radio. And basically I'm going to spend at least 6 months to a year and almost 100,000 USD on that development in terms of sheer engineering services. So ironically, the software of the software defined radios is pretty costly, expensive affair. So how can Quasar help, or how we are trying to help or tackle this exact problem? So why exactly are they costly? In the current way, the red box basically indicates the RF front end and the processing unit, that is the hardware part of the software defined radio, and your custom code here block represents the software part of the software defined radio. The issue here is that everybody is trying to build these softwares from scratch. There are some level of abstraction blocks available in programming languages like MATLAB or GNU Radio, but basically everybody is trying to build this entire stack from scratch. Let's say I want to develop a BLE stack on my software defined radio. There is no source that is directly available out there which can enable the software defined radios to be converted easily into BLE receivers or transmitters, or Wi-Fi or WiMAX, or even your simple 433 megahertz radios with a custom let's say encryption that a person can get started off with, or a developer can get started off with. He has to start from scratch. This is the very reason this software is very costly. As an analogy, this can be compared to people buying theater tickets every time for every single movie, and they are going to the theaters every single time just to see the movie once. So is there a better way to actually tackle this problem? So wherein you don't have to start from scratch or pay every time you have to develop or see something, right? So obviously we all know models like Netflix, which are web-based models with monthly subscription for many movies, and basically you can subscribe once, and then you can watch the movies n number of times, anytime you want. You pay only once, and the content is pretty much shuffled again and again. So it's a pretty good deal than the traditional cinema theater. But although the traditional cinema theater does have its own nuances, but still a pretty big deal and a pretty big way forward from the traditional approach. So similarly, for the SDR world, we have the Quasar App Store. Quasar stands for quasi and star. Quasi indicating something which resembles all properties but is not the exact same thing in math, and star because this actually started with a satellite constellation receiver. So Quasar is a bunch of applications that are pre-built. Some of the applications are on API level, some of the applications are on GUI level, some of the applications are on the JSON level, so that you can get started off with your RF development not from scratch, but Quasar building blocks which enables rapid development of radio frequency signals, adaptive cognitive radios based on software defined radios. So this is exactly what Quasar does. So how does it work, for the users? So you have tons of software-defined radios out there in the market, about 80 to 100 of them, in terms of the developers or the hardware of the hardware-defined radios. Most of us are traditionally familiar with boards like National Instruments, ETIS Research, or the USRP boards, or the Hack RF boards, or the analog devices chipsets, the Pluto SDR, or the RTL SDR dongles, Blade RFs, NU-Elect, so on and so forth. So there are tons of boards that are available, and most of these boards are either on PCIe, USB 3.0, Thunderbolt, or USB 2.0, which enable easy integration bindings with most of them. So with the Quasar API bindings, you can code once and get across all these boards in a matter of seconds. So it's a binding for all these boards, so you can code once and play your signal or receive your signals on any of these hardwares. So you can choose basically the hardware board that you like, that you have, and get started with any of the applications on the Quasar. So the Quasar App Store has a bunch of pre-built applications that are already there for transmission and reception both, and you can get started off with those applications. It also has fundamental building blocks with it, and I'll go more into technical details of how Quasar, how exactly software defined radios can be utilized or leveraged to create, let's say, a broadcasting radio station, or a land mobile radio, or a LoRa signal, or a DBBS2X signal, or even a neurostimulation signal. In fact, Quasar started with the development of IRNSS signal. So generation of the entire IRNSS signal, that is simulation of the entire constellation of IRNSS or Navik, which is the sort of Indian GPS, and actually giving the signal out at 2.4 gig and 1.1 gig bands, so that the IRNSS receivers can be actually tested. In fact, Quasar has been a part of many companies who have been certified on Quasar for AIS 140 certifications for IRNSS or Navik, along with GPS, GLONASS, QZSS, Baidu, and all these satellite communication signals. It can be also leveraged to be used as a spectrum analyzer, or a spectrum sense, waterfall models, generation of CDMA signals, BTS stations, and so on and so forth. So basically what Quasar is trying to do is that give a bunch of building blocks or Lego blocks in the hands of developers, so that they can start off their development in a really rapid way, and that is exactly what Quasar eyes for. It eyes for the democratization of the software-defined radio world. So you can basically choose any board that you like and any app that you like, or multiple apps that you like, and get off with your RF development. So these are the various applications that software-defined radios can be a plug and play kind of model, not only during development or prototyping, but you know there are boards nowadays who are good enough to go directly as into embedded products. And many a time there is this thought that is this an overkill for my application, but the development in the software defined radios, in the current last 2 years has been so good that you can have a complete product out in a, let's say, a month or 2 month period. And that is the beauty of how these frameworks like Quasar are trying to leverage open source boards, not say open source but COTS boards, like analog devices chipset boards, or hack RFs, or the blade RFs, or the USRP boards, or epic boards, or lime SDRs. In fact, we have also indigenously developed an SDR called as the Quasar SDR. So for developers can develop their apps using Quasar custom blocks, or they can also leverage apps from other languages which have binding towards Quasar. Basically, they can they submit their Quasar team. The Quasar team can publish these applications, and then there is a revenue, just like an Android developer developing an Android application and generating revenue from there. Similarly, they can generate revenue from the Quasar App Store. So developers can also generate revenue from the Quasar App Store. Some of the applications are custom built by Quasar. These are our flagship applications, just to get started with the development and enable people to learn how these binding blocks work with each other. So these are the indigenously developed Quasar hardwares. In fact, we recently have launched a smaller version also, which is a 2x2 MIMO. But in any case, the one on the top is the Quasar SDR for satellite communication signals. So for reception, it goes to minus 160 dBm of noise floor, and the bottom one is for 4G, 5G, 6G solutions, in which there is a lot of MIMO scenario in here that needs to be created. So it's a 8x8 MIMO, which can be extended to a 16x16 MIMO facility. So these are two indigenously developed SDR boards by the Quasar team, and which can be leveraged by any of the applications on the Quasar App Store. These are typically high-end SDRs that many of the research facilities look out for, and that is the market that we are eyeing for. But all the Quasar apps are also working with any of the hardwares, not just the Quasar SDR. So basically, what we believe where the software defined radio world is headed is similar to what or how the smartphone world had changed in the last 10 years. So you had Nokia, who was developing their own phones, and they used to build some software just to sell that phone, right? So they used to write some apps, some software just to make that phone working. And then came Android, basically saying that, okay, we are building this platform, and Samsung, you can use it, OnePlus, you can use it, Motorola, you can use it, and sort of a centralized platform so that all smartphones can be leveraged in order to get hold of the same apps and the power from the same apps. Similarly, currently all SDR manufacturers are looking to develop some scratch apps, probably on their GitHub repositories, who basically have a bit of getting started off kind of mechanism for their board. But what Quasar is trying to do is sort of create this application platform with millions of applications, so that there is a boom in this entire software defined radio market. So how exactly the market looks like? So then you have your component providers or chipsets like the analog devices, 839 6 series, which is the most popular in software defined radios, or you have some TI or NI series, so that is there. Then you have, board or subsystem manufacturers, um, basically the blade RFs and the USRPs who have this, Xilinx FPGA or Altera FPGA with a analog devices chipset or a line chipset or so something like that. So the complete board comes together. Then you have application software providers, the most costly ones. Then you have engineering services, the RF plane, the FPGA services, and then the entire radio comes in, and then the end user. Some applications or some developers or some military suppliers do the entire thing in-house, and which is proprietary only to their company. So this is how the landscape for software-defined radio is pretty much situated at. What Quasar is trying to do is sort of have these pre-built applications for all software-defined radios to test on, to work on, to directly fit their software-defined radios into products, to sort of bring down the cost that is there associated with all the software-defined radios. Similarly, Quasar SDR and the Quasar API bindings for different hardwares enable developers to get started off in a really rapid way. So that is exactly what we are trying to do. We are trying to unshackle this legacy architecture, this legacy landscape by technology, and that is what our work lies in, and hope that we find synergy so that we can develop few applications on, let's say, on ham or even software-defined radios that are built by you, so that we can leverage, or you can have a better exposure towards a lot of applications commercially out there. So basically, who uses this software-defined radios, right? So you have your government bodies, regulatory bodies, automotive OEMs, chip OEMs, your medical tech companies, you have your satellite and space tech companies, you have mobile infrastructure companies like Airtel, Jio, and then obviously you have the defense. So that is exactly how this market and the majority of the stakeholders within this market look like. So yes, it is a pretty vast market. The applications are endless, and let's discuss one or two of these applications with the end user, so that we have a better understanding of what exactly we are talking of, right? So some of the Scratch partnerships and basically a consortium of researchers, enthusiasts, amateurs, researchers, companies. All these will come together, form this alliance, so that we can take this way forward, sort of democratize the entire SDR world. I genuinely think that the next revolution that is going to happen, or let's say 6G, should not happen only with the large MNCs and organizations out there, but we should be able to help a person, let's say sitting in his garage, to break through or unshackle the next 6G revolution, or vehicle to vehicle communication. And these kind of platforms, partnerships, associations, events will help us, and I think today's talk is also one of them, to sort of have a consortium, have a synergy to develop faster, develop better, and develop for everyone. So this is what exactly we eye for. On the software architecture side, how exactly it works. So you have direct Quasar SDR modules that are applicable to majority of the vendors, which the Quasar binding or the hardware supports, and with no installations required. You just get on with it. It's basically on Linux and in Windows. Then you can also import devices which have third-party orientation, so you can directly have Osmo SDR or UHD for USRP imported into Quasar, and the Quasar apps bumping on them. So basically National Instruments radios, R or the USRP ones come with the UHD that can be integrated with Quasar, so that the entire all the apps can work with those hardwares as well. So basically, what we are trying to do is sort of go with the philosophy of code once, run everywhere kind of thing, and which is pretty much hard to achieve, but if achieved, then it's nothing or compared to what the existing proprietary things that are in the software defined radios are sort of hamper the entire development chain, right? So then you can obviously have software integrations with platforms or building blocks like GNU Radio, or you can MATLAB. In fact, we have strong compatibility with GNU Radio, to accelerate your development cycle even more. Quasar apps are also blocks that can be directly imported into GNU Radio. Quasar is entirely written in TensorFlow, which is an abstraction over Python. So we can say that Quasar is entirely written in Python. And basically what Quasar does is that instead of using a FPGA based acceleration, it uses AI frameworks like TensorFlow or PyTorch in order for a heuristic parallel engine rather than just an FPGA acceleration. So the aim here is, let's say you want a 6 megahertz clock. So instead of generating the 6 megahertz clock on the FPGA, which is then like a hardware dependent source, what Quasar or does with the real-time parallel engine is, let's say, sample that 6 megahertz on 18 megahertz or 18 mega samples. So it's 18 mega samples that it has to be sampled on in a real-time scenario, and that much amount of data needs to be handled in a real way or in a real time. So using these AI frameworks not for AI but rather for handling that much amount of data in a very heuristic and a fast way is what Quasar actually succeeded in doing, and this is exactly what we believe in. So instead of having that hardware dependent architecture, this kind of parallel engines or a GPU based architecture will enable us to sort of code once and run everywhere on all the SDRs, right? Or even if people are building their own SDRs, they can keep this in mind so that their SDR can be compatible with all the applications that are there on Quasar, right? So it works both ways. There are bindings, API bindings in C, C++, TensorFlow, and Python. So this is how exactly Quasar works like. No installations, no licenses, just a subscription model. The main or the crux USP, I think I went through this, but this is where I personally believe that I again emphasize software defined radios are going towards is going away from the FPGA acceleration or those FPGA blocks and using dynamic offloads to GPUs, HPC clusters, high performance cloud clusters. So you can leverage a real-time engine or algorithm generation source or a waveform generation source, the very good sampling rate from these processing powers, which can be dynamic. So you are not hardware dependent, sort of like the way you are, and this is what Quasar does, and this is how and where we feel that the software, and again I iterate, software defined radios are going towards. So basically we have compatibility, it's with the GNU Radio, with MATLAB, Python, TensorFlow, Java is under progress, and also Visa. So Visa commands can be also used to trigger the Quasar API or the Quasar SDR with Visa commands. It's inherently written in TensorFlow or Python. and now I'm coming more towards the applications. So, from SATCOM perspective, um, so you have your GPS, NAVIC, IRNSS, GLONASS, other SATCOM signals. This is QZSS. This is not UAV. This is QZSS, SBUS, Galileo. So basically, I'll come to the use case later, but AIS 140 compliance requires receivers or GNSS receivers to be at a particular standard, and generation and reception of GNSS signals with advanced scenarios like multipath mitigation and so on and so forth can be achieved easily using software defined radios. Both the transmission and reception of GPS signals, GNSS signals is a huge automotive field for software defined radios. In fact, a few moments later, I'm going to go into depth regarding how exactly this can be used or what exactly is the application I'm talking about. Electronic warfare apps. By the way, all these apps and logos are the apps on the Quasar App Store. All these SDRs can be leveraged and can be used to create these apps or to sort of synthesize or use these apps. So you can use that Blade RF to create a GPS spoofing or MANET or a spectrum analysis, or you can use that USRP or RTL-SDR dongle directly and get started off. So recently, around 11 February, we launched 5 new apps in the electronic warfare. The pulse descriptor word detection, multi-emitter scenario generation with advanced Dopplers, threat simulation for EW, electronic warfare, jammers. In fact, now we are working on anti-jammers and anti-spoofers using SDRs. So the development is fast, the development is rapid, and the best part is, the bad part is that we have to be always or the radio has to be always one step above the enemy. And for that same reason, it has to be dynamic, it has to be cognitive, it has to be more than that, it has to be intelligent. And this kind of rapid development will only be sort of the only way in which that radio or that software defined radio is going to be dynamic. So this is exactly what we are trying to achieve, and I hope that we have the synergy so that with your SDRs, with the framework, with parallel engine, we can create more applications. Let's say the meteorology balloon or balloon, so that you can send data from the balloons down to sky, or even SATCOM companies are now working on long CDMA, which is an abstraction over CDMA technology used in the telecom sector to beam internet from the sky. So recently, yesterday itself, I think it was in the news that Starlink broadband from Tesla SpaceX is now available for India also. So you can have those look at the prepaid plans, but exactly how they are doing this. So developing you're utilizing software defined radios for that, right? So we can look at that also. So this brings me to the telecom act section. 5G, pre-5G, so basically the 5G overhaul, GSM, CDMA, LTE, LTM, the Tata Sky boxes, DVB-S2, DVB-S2X, LMR, the police walkie-talkies, broadcast radios. I think with this section, I think this resembles more. But basically, the interesting part is not from an application perspective, but just from a simple try and error basis. If we keep a simple Blade RF or a hack RF in front of the Tata Sky box and we give a DVB-S2 signal, we can actually see a different video on the set-top box than the one which is receiving, which is terrifying, but which is true. So software-defined radios can be easily configured for telecom applications as well, and these applications are nothing but different apps with bindings and APIs on the Quasar App Store. Obviously, IoT is the booming world, and most of these applications require different kinds of wireless protocols. Zigbees have came a long way. I think 4 or 5 years ago, the consortium has been good. The support has been good. So then you have protocols like LoRa or Sigfox for long distance communications. You can create your own Wi-Fi stations using software-defined radios as access points directly, or repeaters directly, or you can also send narrowband signals like NB-IoT or LTE or Bluetooth with software-defined radios. So yes, as I was saying, basically these are some of the companies that can be directly compatible with the Quasar App Store. So this is how the App Store looks like. I hope that we have the synergy and we can probably integrate more and create more applications over this App Store, so that just to spread software-defined radios, enable other researchers, developers, amateurs, hobbyists, tinkerers to get on with their software-defined radio development. So, as a use case and a complete application, Quasar enabled a ARAI for a complete IRNSS, GPS, GLONASS and Baidu signal generation and reception, and we are proud to say that it is today used for AIS 140 certification. In fact, we didn't even stop there. As Quasar is inherently written in TensorFlow, we integrated easily various AI technologies with software-defined radios as well to create a very coherent and massive application for multipath mitigation. So, like a majority of SATCOM signals, GPS or NAVIC or IRNSS is also a line of sight signal, and basically the error that is there with these signals, along with the models of ionospheric and tropospheric errors, is also multipath mitigation. What multipath mitigation is that the signal bounces off on walls and comes to the phone or the receiver, and that creates a small time distance between the actual signal and the received signal, which essentially is taken into deviation in distance, and therefore the accuracy of the receiver is not achieved. So how to mitigate those multipaths and how to integrate cleverly different technologies together cohesively is what is demonstrated with this application. So let's say we want to find out the sources from where this application is going to sort of interact with these right? So now it is loading. So we start off detecting 2D objects around it, which are going to bounce the signal back. So this is a real-time engine again. So sort of the receiver is trying to gauge from the cameras what are the different sources around me which are going to bounce off the signals. So sort of being more aware of my environment, going more towards cognitive radio, right? So this is simple 2D object detection. Then we go towards 3D object detection. So we fuse LIDAR data along with the 2D object detection. So we then do a 3D object detection and then associate different reflective coefficients for the signals on these walls, right? So you do a 3D object detection in real time with LIDAR data infusion along with the camera for 2D object detection. Based on that, you then sort of superimpose both of these signals to create a HD map and sort of analyze and see which satellites are the ones having a biggest multipath and how to mitigate that. The yellow line represents the line of sight from satellite to the car. So you just forget the satellites that are having a lot of bouncing off and coming back to the coming to the receiver. So you sort of ignore them directly or become more cognitive as a radio. And this is in real-time parallel engine. I also like to thank AutoWare a open source autonomous vehicle simulator, which was used along with the Quasar app to create such a complex scenario. So, the car at ARAI is Automotive Regulatory Authority of India, is actually sitting within the lab itself, but actually such advanced scenarios are created, and the receiver is then uh, exposed to these scenarios, and then the sort of to make it more adaptive, more cognitive, more edge analytics, more sort of more intelligent. And this is how exactly, instead of creating a ideal signal with software defined radios and ideal reception with software defined radios, we can actually leverage this to become more cognitive or to become more aware of the surroundings. This is very useful, especially while MIMO or 5G in urban environment, wherein you require your receivers and transmitters to be very adaptive, also in electronic warfare. So this is then you can obviously create HD maps, so you can sort of say that okay, I want to go in this way, and then sort of embed the Quasar app to this, so that you create a complete path planning mission. So let's say you have on the electronic warfare side a bunch of UGVs or UAVs that need to be traversed, and basically are going to respond with DGPS or differential GPS. Then such kind of testing scenarios, and even in prototypes, or not even in prototypes, even in the actual receivers or actual UGVs, software defined radios can be cleverly leveraged in a cognitive or an intelligent or an AI way. So my job was to probably trigger you to more or think more on the lines of the possibilities of different applications with software defined radios, and hope that applications like this trigger you and sort of help you to build your SDR applications in a really rapid way. With that, I'd like to conclude session, my talk. I'm once again thankful for the entire society, Rabde sir, for this opportunity, and hope that we find some synergy so that we can work together. Your SDRs, our apps, our SDRs, your apps, so that the software defined radio world is more closer together, and we can build a better sort of future and get on with the development in a really rapid way. So thank you once again, and look forward to meeting you really soon, and hope all of you are safe. Thank you once again.
Thank you, big thank you to you, Siddharth, for a lovely presentation. Pune Hams really appreciate your presentation. We will allow some time for the internet delay, and then we will start the question and answer session. And then Mr. Dilip Bapat will take over to pull in the late check-ins, and those whom he taken by Siddharth for presenting this Pune Hams today. And definitely the software defined radios are the future. Those who are using IC 7300 are already enjoying the benefits of SDR. So thank you, Siddharth, for this wonderful presentation, and we are going to have an eyeball today evening, and Pune Hams will have a dinner program along with Siddharth, and we will be having his presentation once again and some interaction. So thank you very much, Siddharth. I will hand over to Dilip Bapat for the next proceedings, and we can start the question and answer session. So over to you, Dilip Bapat.
Siddharth, such a nice presentation, really amazing, and happy to listen all those things. And definitely we'll ask for a question, but then I heard that Siddharth is not available for equaling. So let us ask the questions, note down those questions, and then we'll discuss on that at the dinner session. Is it QSL, Rabde sir? Go ahead once again.
VU3UEL with VPR is 100% QSL. Please note down the questions or WhatsApp or SMS to time today. And definitely, it is relevant to mention here the efforts taken by Atul, VU3OPY. This is the first time he has handled the YouTube live program for Pune Hams, and we really appreciate his efforts, and supported by VU3 Oscar Uniform Mike Oldman Mangesh, who trained him, and now Mangesh can take up the another responsibility. So let us divide different activities so that as a group, Pune Hams will definitely scale new heights every day. Thank you very much. 73 to everybody, and over to you, Dilip.
Yes, Roger. Thank you very much, VU to VPR update, sir. First of all, for providing such a nice presenter for today's Tech Talk. Definitely, really a great information he shared with us. And of course, Atul Kulkarni, sir, first time doing this YouTube live program for Pune Hams, but definitely this experience will help him a lot, and that will also one of the positive thing for Pune Hams. Other than OUM, we have got one more person who will be handling this YouTube live properly. So thank you so much, Atul Kulkarni sir. And first of all, I am giving mic here in on YouTube. On Ecolink to let us know about the program, how they feel about this program, or what they wanted to say about this program, and of course any questions anybody wanted to ask for. And if anybody wanted to ask questions, definitely your questions will be discussed at today evening dinner party will be is arranged by VPR sir there with our presenter Siddharth today. So this is the information for everybody. But before moving ahead, first of all, I am putting mic to VU3 OU Oscar Papa Yankee. Atul Kulkarni sir, go ahead. What a nice presentation you provide by your efforts. Of course, presenter is Siddharth, no doubt. Go ahead, Kulkarni sir. Good morning.
VU3 Uniform Echo Lima, this is VU3 Oscar Papa Yankee with VU3 OPX. So, good experience today I had of going to YouTube Live, how to coordinate with all the mobiles and laptops and all that. Even the presenter was good. He has sent the presentation in time so that I can do my job with the help of VU3 OUM and VU3 OPX properly. So nice experience today I had. So I thank also VU to VPR also for giving me this opportunity. So over to you, Uniform Echo Lima. This is VU3 Oscar Papa Yankee along with the VU3 OPX standing by.
Yes, Roger. Thank you very much. VU3OPY Atul Kulkarni sir doing excellent job today for presentation of this YouTube live program for Pune Hams with, of course, the great ma'am, my favorite Monica ma'am, VU3 Oscar Papa X-ray. She is with you. Really happy to see that she is helping you a lot there. And of course, OUM definitely all the time with us, no doubt about it. So you three made it possible. Thank you so much. And one request is for you that if any YouTube question is there on the YouTube platform, so please note down that, and we'll definitely share all the questions, answers in today's evening tech talk. Evening net. This is for your information. Thank you so much. And now I am going to our equaling stations. Equaling stations, thank you so much for joining and remaining on the frequency so long. And first of all, I am giving mic to our great DX station, John sir, joining and remaining on the frequency almost hour or so with us from Florida, South Florida, USA. Whiskey November 4 Victor. John sir, go ahead. Let us know what you wanted to say about this.
Victor Uniform 3 Uniform Echo Lima WN4B delivered very comprehensive, very comprehensive coverage of web SDRs, I mean. And if this it will stay on YouTube, I intend to watch it again. Again, very comprehensive. I don't have any more comments at this time, but I'm going to recommend it to friends of mine as an excellent presentation. And at first I had trouble with the link, but once I got the link entered in correctly, there was no problem. So thank you very much, and back to you, VU3UEL WN4V.
Yes, Roger. Thank you very much. Whiskey November 4 Victor, John joining from South Florida, remaining on the frequency, watching entire YouTube live program, sharing your views regarding today's program. I'm really happy to listen from you. And do join us today, evening net. That will be the morning net for you. For the time being, good night. And 73 is bye-bye. Enjoy the weekend. Now VU2RDX. Shekhar sir, come in please. Good morning. I know that you joined us late, but definitely YouTube live program is available on YouTube after some 10 or 15 minutes. So you will get entire program once again if you wanted to watch it. But let us know if you are joined late and watch that YouTube live. VU2RDX, go ahead Shekhar sir. Good morning. Kale Vadakkam. VU2RDX, come in please. Okay, he must have some issue there of connectivity. No problem. So friends, I am Dilip Bapat, Victor Uniform number 3 Uniform Echo Lima. Once again, thanking all the stations who join via VHF repeater and echoing to Pune morning net. Hope to meet everybody today evening net, and we all enjoyed today's great tech talk presented by Siddharth and produced and delivered by Atul Kulkarni sir, that is VU3 Oscar Papa Yankee with Oscar Papa X-ray and great help from VU3 Oscar Uniform Mike. So these are the three behind this great presentation today. And thank you so much, Siddharth. If you are listening, really happy. You did a fantastic job. What a nice presentation you produced for this Pune hams. I'm really happy. I will not join you for the dinner party, but who is listening to me, convey my regards and namaste and congratulations to Siddharth. 73 is good day all around. Enjoy the weekend. This is View 3 Uniform Echo Lima with all Pune hams and all the stations listening. Going QRT. Bye bye. Good day all around.
Okay, Dilipji, also the who has presented the session. Thank you very much. Have a nice Sunday. We'll catch you all today night. Bye-bye. V3 Uniform Echo Lima on the group V2 RDX. Signing clear. Bye-bye.